Number 4 says, Party City has 138 styles of Halloween costumes. Oh, I forgot to underline that, my bad. They have 24 sizes of each style. How many costumes does Party City have all together? So again, I went in and I underlined the numbers that I know I'm going, or that I figured are important, and they are. So we have 138 and 24. And now we need to figure out what type of math we are doing. Since it says all together, and we have this nice word here that says each, this lets me know, okay, we're multiplying, because all together means we're putting all of this information together. We're not separating it, we're putting it all together. And when we use the word each, that means we're multiplying. So I'm going to put an X here to show, or my multiplication symbol here, to show that we're multiplying. And then I'm also just going to write a little note on the side. So now I'm going to set up my standard algorithm. Going to box the number in my ones place, so I know, okay, this is the main number I'm focused on right now. I'm going to multiply 138 times 4. 8 times 4 is 32, put my 2, carry my 3. 3 times 4 is 12. 12 plus 3 is 15, put my 5, carry my 1. 1 times 4 is 4. 4 plus 1 is 5. I'm done multiplying by the 4 in the ones place. I'm going to mark out the numbers I don't need. And then I'm going to put that 0 to show that I'm moving on to the number in the tens place. So now, I can multiply everything by 2. 8 times 2 is 16, put my 6, carry my 1. 3 times 2 is 6. 6 plus 1 is 7. And then 2 times 1 is 2. Now I'm going to add. 2 plus 0 is 2. 5 plus 6 is 11. 1 plus 5 is 6. 6 plus 7 is 13. Put my 3. Carry that 1. 1 plus 2 is 3. So before I circle this as my final answer, I'm going to check my work. So 138 times 24 is 3,312. So that is our answer, but remember, I want to write my, I want to put my answer in a sentence to show that I know what it is I'm talking about. So the question, remember, says, how many costumes does Party City have together? Our sentence can simply say, Party City has 3,312 costumes all together. And that is our, there you go. That is our sentence for this problem. All right, now I'm going to scroll to the next page of problems. All right, number 5 says, Mrs. Torres's 5th grade class scooped 494 seeds out of a pumpkin and roasted them. The seeds were divided evenly among the 23 students in the class. How many seeds did each student receive? How many were left over? So the first thing that I see that I know for sure that I need to solve my problem are the numbers I'm using. So the numbers I'm using are 494 and 23. Now I need to figure out what type of math I'm doing. Now there is actually one keyword in there that we really only needed that lets us know, oh, we're dividing. And it's this word right here, divided. If you see in the word problem that something was divided evenly, that means we are dividing to find the answer. So I'm going to put my division symbol and then put an asterisk over here, write a little note that, okay, we are dividing, or this is division. So now I'm going to set up my standard algorithm. 494 goes in my dividend because it is my dividend. And 23 is my divisor because that's the number I am dividing by. Now, I need to figure out the answer. 23 can't go into 4, so I'm going to move it over and see how many times 23 can go into 49. I'm going to have to multiply by a random number because I don't know this at the top of my head. So I always like to start with 5 because that's our nice little median, and that will let me know if I need to go higher or go lower. So over here, we're going to do 23 times 5. 3 times 5 is 15. Put my 5, carry my 1. 2 times 5 is 2 times 5 is 10. 10 plus 1 is 11. Woo! 115 is a lot higher than 49. So 5 and higher would definitely not work. So I need to go lower. So I'm going to multiply by 2 and see if that gets me any closer to 49. 3 times 2 is 6. 2 times 2 is 4. 46 is a lot closer to 49, and honestly, I think if I went up 1 higher, I would go over 49. So I'm just going to stick with 46 because that's as close as we're going to get. So I'm going to put 2 over here above the 9, and then 2 times 23, we did over here, gave us 46, so I'm going to subtract. 9 minus 6 is 3. 4 minus 4 is 0. Now, I need to bring down that 4. Now I need to see how many times 23 can go into 34 evenly. Well, over here, I already multiplied by 5, and that gave me 115, which is a lot higher than 34. And over here, I also multiplied by 2, but that gave me 46, which is also higher than 34. So if it's not 2 and we need to go lower, what's going to be the number we're going to use? If you're saying 1, you're correct, because 1 times 23 is 23, and that gets me underneath 34. We want to get as close to 34 as possible without going over. So now, I'm going to subtract. 4 minus 3 is 1. 3 minus 2 is 1. So our answer is 21, remainder 11. Remember, your remainder always has to be lower than this number. If your remainder is higher than your divisor, then you did something wrong somewhere, because you cannot have a number remaining that is higher than your divisor. Okay, so another way to make sure that you are on the right track is that if your remainder is less than your divisor, then you're on the right track. If it's higher, then that means we messed up somewhere, okay? So now, before I am officially finished, I want to write my answer in a sentence. So the question says, how many seeds did each student receive? How many were left over? So our sentence can say, each student received 21 seeds and there were 11 seeds left over. And this is what our sentence can look like.